Now, today in this mathematics session, we are going to discuss few points related to the centroid of the triangle. I have around about 10 points to discuss with you related to the centroid of the triangle. Right? See, first point is the definition of the centroid. So, go with the point wise. The first thing related to the centroid of the triangle is the first point is definition of the centroid. See, if you have a triangle consists of three vertices, three sides, name the triangle as ABC. If ABC is a triangle, then the line passing through the one vertex and to the midpoint of opposite side. You may say the midpoint as some D, right? D is the midpoint of opposite side. See, A is the vertex, D is the midpoint of the opposite side. Then if you join these two, vertex to the midpoint of opposite side, this line is usually termed as median of A for triangle ABC. Just observe it. This line is the median of A for triangle ABC. Likewise, if you continue, if this is the midpoint of the side AC, then if you join BE, this is the median of the triangle BE, median of B for triangle ABC. And similarly, if F is the midpoint of this side, this is F also midpoint. If you join this F along with the vertices, then this CF is median of C for the triangle ABC. Since there are three vertices, if you join a vertex to the midpoint of opposite side, you will get a median. Since there are three vertices, automatically you will get three medians in the triangle, and those three medians will concurrent at a point, and that point of concurrency is termed as centroid of the triangle. Keep in mind that centroid is nothing but the point of concurrency for the three medians of triangle, right? And one more thing related to that centroid is, if you consider any median, see I have now three medians in this triangle ABC. AD is one median, BE is another median, CF is another median. Now if you concentrate on one median AD, on this median somewhere centroid is located. Somewhere we have G on this median. See, that centroid always divides this median in the ratio 2:1. Keep in mind that centroid divides median in the ratio 2:1 from vertex to the side. See, in vertex side it is two parts, and in side side it is one part, right? So basically here you need to memorize three different things. First thing is, what is median? Line joining from a vertex to the midpoint of opposite side is the median. Second thing is, there are three medians and the point of concurrency of those medians is the centroid. Whereas the third thing, centroid surely divides a median in 2:1 ratio, two parts in vertex side and one part in the sidewise. See, if you took the points as x1, y1, x2, y2, if A x1, y1 and B x2, y2 and C x3, y3. If you have three vertices x1, y1 and x2, y2 and x3, y3 for the triangle ABC, then you just think about D. What is D? This D is surely midpoint of BC, as I mentioned you. And you know the formula to find the midpoint as x2 plus x3 by 2, comma, y2 plus y3 by 2. Think again. See, I have a triangle ABC with the vertices x1, y1, x2, y2 and x3, y3. D is the midpoint of BC, and the D can be found by using midpoint formula, that x2 plus x3 by 2, comma, y2 plus y3 by 2. So this is D. Now when you coming to the concentrate on median, A, you know the vertices as x1, y1. D, just we found that vertices of the D as x2 plus x3 by 2, comma, y2 plus y3 by 2. Now if you have a look, this A, D is divided by the centroid G in the ratio 2:1. Now, you know that section division formula. Since the centroid is dividing AD in the ratio 2:1, if you apply section division formula for this line segment, you will get the coordinates of G, centroid coordinates M, x2 plus N, x1. You need to do that cross thing. 2 into this value plus 1 into this value by 2 plus 1. If you apply section division formula for this line segment, you will get the coordinates of the centroid as x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. So from the basic definition of the centroid, we found the formula to find the centroid of a triangle if x1 by 1, x2 by 2 and x3 by 3 are the vertices. And that centroid is given by the rule that x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. You need to memorize all these things, right? What is median, what is centroid, what is the property related to the centroid, and what is the coordinate geometry, two-dimensional formula to find the centroid, right? Two-dimensional formula is this one, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Geometrical property is centroid divides median in the ratio 2:1, whereas centroid means point of congruency of the three medians, and median is the line joining vertex to the midpoint of opposite side. Just have a look and go for a screenshot. I will give you different problems related to this centroid now. This is completely first point related to the centroid of the triangle. Do first. See, after this first point, I may give you some problems. You just keep in mind that centroid of the triangle is x1 plus x2 plus x3 by 3, whereas y1 plus y2 plus y3 by 3. We may face different problems related to this. For example, second point related to the centroid of the triangle. For example, triangle ABC is known. For the triangle ABC, vertex A, vertex B and centroid are given. Then they ask you to find vertex C. How can you do? For suppose vertex A, I have few problems with me right now. See, vertex A is if we take it as 3 comma minus 1, whereas vertex B is minus 1 comma 5 and vertex centroid is 0 comma 0. Then what to say about the coordinates of vertex C? Look at the problem. You don't know the third vertex C of the triangle. Since you don't know the vertex C, you need to let the third vertex as alpha comma beta. If you let the third vertex as alpha comma beta, then as per the formula, use this A, B, C. Then what is your centroid? Then as per that formula, centroid is x1 plus x2 plus x3 by 3, right? So 3 minus 1 plus alpha by 3. Add the x coordinates of these three vertices and add the y coordinates of the three vertices. That centroid is given like 0 comma 0. Now you need to simplify. See, you equalize the corresponding x coordinate as well as the y coordinates. This simplification is 2 plus alpha by 3 is equals to 0, and this simplification is 4 plus beta by 3 is equals to 0. And from this it is very clear that alpha is minus 2 whereas beta is equals to minus 4. At the end, the third vertex of the triangle is minus 2 comma minus 4. And this is the way to solve this type of problems. Think once again. Just I mentioned you in the first point that centroid is sum of x coordinates by 3 comma sum of y coordinates by 3. Now in this problem, vertex A is given like 3 comma minus 1, vertex B is given as minus 1 comma 5, and vertex C you need to find if centroid is known as 0 comma 0. So since you are going to find vertex C, let that vertex C as alpha comma beta, and now apply centroid formula for this ABC, which is nothing but sum of x coordinates by 3. 3 minus 1 plus alpha by 3. Sum of y coordinates by 3. Minus 1 plus 5 plus beta by 3. And this centroid is given in the problem as 0 comma 0. And if you equalize the corresponding x coordinates as well as y coordinates, your answer at the end is alpha is minus 2 and beta is minus 4, and that third vertex is minus 2 comma minus 4 for the triangle. This is something about a problem related to the centroid, right? And I will give you one more problem here. Just have a look. Yeah, I am erasing this. For example, I have a problem related to this. See, third one. I have a triangle ABC. Think why? The point A is given as sum 1 comma minus 2, and the point D, which is usually the midpoint of BC, is given as, you may say something like 3 comma 0, right? And now they ask you to find centroid. What is the centroid of the triangle, right? See, the general formula for the centroid of the triangle is x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. But in the question itself, they are asking you to find the centroid by knowing A and the midpoint of BC. How to find? See, as we discussed, you know that if you have that median AD, see this D is the midpoint of BC. If you join AD, it becomes like median only, right? So this point is 1 comma minus 2 and this point is given as 3 comma 0. Surely centroid lies on this median and it is dividing the median in the ratio 2:1. Now without using the direct formula as x1 plus x2 plus x3 by 3, you need to use this ratio technique here. How the centroid you will calculate? Now the centroid is equals to mx2. I think you are familiar with this. mx2, that is in the sense 2 into 3 plus nx1. 1 into 1 divided by 2 plus 1, comma my2, 2 into 0 plus ny1, 1 into minus 2 divided by 2 plus 1. And if you simplify, this is 2 3 is 6 plus 1, 7 by 3 comma 0 minus 2 by 3. So now this is the centroid for the given triangle. Have a look, observe it. See, as for the problem, it is given that they ask us to find the centroid, but instead of 3 vertices of the triangle, they gave you the one vertex A along with its opposite midpoint. Now A is there as 1 comma minus 2, midpoint of the opposite side is 3 comma 0. To find the centroid, you need to utilize this technique. What it is? Centroid divides median in the ratio 2:1. With that trick you found that centroid is equals to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, and your centroid is 7 by 3 comma minus 2 by 3. Have a look and I will give you few more problems related to this. Yeah. See, we need to think about few more tricks related to the centroid without solving all those things. See, the third point related to the centroid, what I am going to tell you is, just look here. See, I have a triangle. I have a triangle ABC. See, you just consider that A as x1 y1, B as x2 y2, C as x3 y3, and you may take 3 points on the 3 sides such that those 3 are dividing the sides in the same ratio. What I am going to tell you is, I have a point, say some P, which is dividing BC in the ratio m:n. In the ratio m:n, and I have a point Q on CA, which is dividing CA in the ratio m:n, and I have a point R on AB, which is dividing AB in the ratio m:n. Any ratio you may take m:n, 2:1, 3:4, like that, anything, right? A x1 y1, B x2 y2, C x3 y3 are given. P, Q, R are 3 points on the side such that they are dividing the sides in the same ratio. Now you are able to find this P and that Q and that R also. And after finding the coordinates, if you check, you have a beautiful trick here. It is centroid of triangle ABC is equals to centroid of triangle PQR. See, if they ask you to find the centroid of the triangle PQR such that PQR are the vertices on the sides dividing ABC in the same ratio, then in such a case, if you found the centroid, that centroid is just equal to the centroid of the triangle ABC. As an extension of this, in generally you may face these type of problems. For example, you have a triangle ABC. This is the triangle ABC. And if you took the midpoints as DEF are the midpoints of the sides, right? This is triangle ABC. And if you join this DEF, if you look at the two triangles, the internal triangle DEF as the outer triangle ABC, centroid for both the triangles are same. What I am going to conclude you is centroid of triangle ABC is equals to centroid of triangle DEF, right? You may face different problems. For suppose, as a question, just a minute, excuse me. Yeah, for example, I have the vertices of DEF. D is given as 1 comma minus 2, E is given as 3 comma minus 4, F is given as 0 comma some 6. And now they ask you to find the centroid of triangle ABC. You don't know the coordinates of ABC, you have the coordinates of DEF, still they are asking you to find the centroid of ABC. Now, just don't go with the confusion, just find the centroid of triangle DEF. That centroid of triangle DEF also works like centroid for the triangle ABC. So this is one beautiful point which is helpful to solve many questions, right? See, actually there exist ABC, 3 vertices, PQR, more 3 vertices. There instead of PQR, specifically we are mentioning DEF. Here the ratio is m:n, there the ratio is 1:1. Think a while carefully. So what I am going to tell you is PQR given, and they ask you to find centroid of triangle ABC. No problem, just find centroid of triangle PQR, that's enough. ABC are given, and they are asking you to find centroid of triangle PQR. No problem, find centroid of triangle ABC, and that is your required answer. And this is somewhat fourth point related to this centroid what we are discussing now. Just go with the screenshot. I will give you few more problems right now. Just go with the screenshot. Right. The fifth point related to the centroid. Length of the median. Another thing which you need to learn. Fifth one is the length of median. Just have a look. For example, if you have a triangle. If you have a triangle ABC, right? Through the vertex A to the midpoint of BC, we can draw a median. What is the length of this median AD? See, there are two different ways. If you have vertices x1, y1, b, x2, y2, c, x3, y3, just find D. Just find D and then find the median. Okay. See, what I am going to tell you is if vertex A, x1, y1 is given and vertex B, x2, y2 is given and vertex C, x3, y3 is given, you just find coordinates of D as x2 plus x3 by 2 comma y2 plus y3 by 2. With this midpoint formula, this is the vertex D. You know the coordinates of D, you know the coordinates of A, then just find the distance between these 2 points using distance formula. That is the length of median. I think it is clear for all of you, right? If 3 vertices are given, to find the length of median, you just move using distance formula for these 2 coordinates. For an instance, if vertices are not given, what I am going to tell you is, if vertices are not given, I have a triangle ABC, right? I don't know about the coordinates of A, coordinates of B as well as coordinates of C, but the lengths are given, right? See, this length, for an instance, you may take it as some A, and this length is some B, this length is some C. Coordinates of ABC are not known for me, whereas the side lengths are known as ABC. Now if anybody asks you to find the median from vertex A to the BC, this is okay, this median through A, right, we call it as length of median through A. Length of median through A is given by the rule that half of square root of 2b square plus 2c square minus a square. Just have a look, this is symmetrical. Since we are finding median through the vertex A, you will get 2b square 2c square minus a square. If it is through B, if you wish to find length of median through B, then the formula is half root of, here you need to write minus b square, and here you need to add 2c square and 2a square. Similarly, you will get the length of median through C also, right? See, once again, just have a look related to the length of median. There are 2 different cases, 2 different types of problems related to the length of median. In one case, vertex A, vertex B, vertex C are given. If the coordinates of these 3 vertices are given, you just directly find vertex D and use distance formula for this length AD. That is your median. Whereas, instead of the coordinates of these 3 vertices, if side lengths are given as ABC, length of side BC is given as A, length of side AC is given as B, length of side AB is given as C. And if you have the vertices side lengths ABC, then length of median through A, this AD, is given by the rule that half 2B square plus 2C square minus A square, and median through B. There is another median like this, right? From this vertex to the opposite side. That length is given by this rule, half 2C square plus 2A square minus B square. And in the same way, you are able to write the length of median for the through the vertex C also, right? So this is something about the length of the median, right? And based on this, you need to arrive another situation. What I am going to tell you this is this is something about the length of median. You just memorize this formula to find the length of the median at any case after having the side lengths, right? Now what I am going to tell you is sixth one. Just take a triangle ABC, and for this triangle you may say sides are ABC. If the sides are ABC and you just say length of medians, you may say MA, MB, MC. MA is the length of median through A, MB is the length of median through C. Now MA, length of median through A, is given by the rule that half root of 2B square plus 2C square minus A square, and length of median through B is given by half root of 2C square plus 2A square minus B square, and length of median through C is given by half root of 2A square plus 2B square minus C square. And just observe all these things. See, if you observe all these things, what will happen? From this we can arrive a new situation that there are three sides in a triangle and there exist three medians in the triangle. If the three side lengths are ABC and those three median lengths are MA, MB and C, the length of median through A, B, C are given like this. If you square and add all these three, what I am going to tell you is MA square plus MB square plus MC square is equals to, if you square it, what you will get? 1 by 4 of this square root will get cancelled. 1 by 4 of this square root will get cancelled. 1 by 4 of this square root will get cancelled. And if you add all these things, you left with 3 by 4 of A square plus B square plus C square. This is one important trick related to the medians and then sides. What it is? Sum of squares of medians. Sum of squares of medians in a triangle is equals to 3 by 4 of sum of squares of sides. So this is also you need to keep in mind to solve some different situations, right? Just have a look. In the fifth point, we discussed about the length of median as half root of 2b square plus 2c square minus a square if sides are given. And sixth point, we discussed about relation between the sum of the squares of the medians along with the sum of the squares of the sides. Is it clear? Right? See, they may ask you in a problem related to this. For example, see, I have a triangle. Sides of triangle. Sides of triangle are given by something like 3, 4 and 6. You may say some 3, 4, 6. Right? Sum of the sides of triangle is 3, 4, 6. And then they ask you to find sum of squares of medians. Sum of sides are given as 3, 4, 6. Sum of the squares of medians they ask you. Then directly you can find that as 3 by 4 of the squares. 3 square plus 4 square plus 6 square. If you simplify this, and that is your answer, sum of the squares of the medians with the sides of the triangle. Just have a look, go with the screenshot, and I will give you few more results related to the centroid of the triangle. Yeah, just note everything. All these things are helpful to solve the problems, okay? The next seventh point related to this is just have a look. The seventh point related to this triangle centroids is, for example, you have a triangle ABC. This is triangle ABC, right? And you just consider the midpoint of the sides. D is the midpoint of side BC, E is the midpoint of side AC, and if you say F is the midpoint of side AB, right? If you join all these three, D, E, F, and if you observe, there exist four different triangles in the diagram. This inner triangle is the triangle formed by the midpoints of the sides, and this is triangle ABC, and totally there exist four different triangles. And if you think about all these four different triangles, all these four triangles are congruent. That in the sense, if they ask you to find areas of triangle ABC or everything, areas of all these four triangles are equal, and each area is equals to, for an instance I am mentioning here, area of triangle DEF is equals to 1/4 of the area of triangle ABC. All these four areas are same. So if you wish to find any one area, that area is 1/4 of the total triangle, right? This is one beautiful thing which you need to memorize, right? And one more thing is, if you observe it, all these 4 points, for example, look here, D, C, E, F. These 4 points will form a parallelogram here. These 4 points will form a parallelogram. Not only these 4 points, if you will think about these 4 points like B, D, E, F, these 4 points also make one parallelogram here. Not only these 4 points, if you think about A, F, D, E, these 4 points are also making another parallelogram. That in the sense, keep in mind that if D, E, F are the midpoints of the sides A, B, C, then all these 4 triangles of equal areas, that is one important task. And the other thing is, there exist 3 different parallelograms. D, C, E, F, one parallelogram, B, D, E, F, another parallelogram, A, E, D, F is the third parallelogram. So now you have a chance to utilize the properties of parallelogram also if you need, right? And one more thing related to this is, what I am going to tell you is, for example, I have a triangle. Yeah, just have a look. I have a triangle like this. I have a triangle, and you just take the vertices as midpoints of the sides as D, E, F. See, this is the triangle ABC, and D is the midpoint, E is the midpoint, F is also midpoint of the sides. Right? Now, for example, I have the coordinates of this D, E, F. You may say that D has -1, 1, E has 2, -3, F has something say 4, -5, 4, 5. Just a general points I took here. 1, -1, 2, -3, and 4, -5. If these 3 are the midpoints of the sides, and now they ask you to find the coordinates of A, B, C. How to find the coordinates of A, B, C? Right? I will give you one task. See, to find the coordinates of A, B, C, you just think about this parallelogram right now. See, this is the parallelogram here. Since this is the parallelogram, as I mentioned you, see, you know the 3 coordinates as 4, 5, 2, -3 and 1, -1. Then what to say about C? Now if you wish to say about the coordinates of C, you need to add these 2 and subtract this 4, 5, as we discussed in yesterday's class. So that means the coordinates of C, the x coordinates of C as sum of the x coordinates of these 2, 1 plus 2, 4, comma, sum of the y coordinates of these 2, -1, -3, minus this y coordinate, -5. And if you simplify, 3 minus 4, -1, comma, this is -8. So this coordinates of C are -1, -8 by considering this parallelogram. In the similar manner, if you think about this parallelogram, what is the parallelogram? B, D, E, F. If you think about this parallelogram, again you have D, you have F, you have E. Now for this B, just think about this B. How it is there? For this B, these 2 are the nearest and that is the farthest. You need to add these 2 and subtract that E. So the coordinates of B are given by sum of the x coordinates of these 2 points, 1 plus 4 minus subtract that x coordinate 2. And as y coordinate, sum of the y coordinates of these two, -1 plus 5, and subtract that y coordinate, minus of -3. And if you simplify, 5 minus 2 is 3, and this is 5 minus 1, 4, minus of minus plus, that in the sense 7. See, very simple thing. Don't get confused, okay? Just be concentrate. I am mentioning you few properties related to the midpoints of the sides. Once again, I am going to tell you, here it is. I have a triangle ABC, right? DEF are the midpoints of the sides, right? Now if you look, there exist 4 triangles here, okay? And these 4 triangles will have same areas. That was one important task. That it in turn represents that each area is the 1/4 of the total triangle. Is it clear? Now one more thing is, if you concentrate on any 4 points like this, these 4 will form one parallelogram, these 4 will form another parallelogram, these 4 will form a third parallelogram. Now my question is, if you have the midpoints of the sides of the triangle as like this, and they ask you to find the coordinates of the vertices, how to find? To find the coordinates of the vertices, you need to think about the parallelograms one by one. And now, if you think about this parallelogram, for this parallelogram, DFE, 3 vertices are known, and we are going to find the 4th vertex of parallelogram. And as I mentioned you in the previous class, this 4th vertex, we found it by adding the nearest x coordinates and subtracting the farthest one. Like that I found C. Similarly, to find B, add these two and then subtract that farthest E. And for A, if you wish to find, add this F and E and subtract D. You need to keep in mind the trick that if you wish to find the coordinates of E, you need to add F and E and subtract D. Since F and E are nearest, add. Since D is the farthest, do subtraction. Right? So this is something about the areas related to the midpoint, areas, centroid, and everything related to the coordinates ABC along with the midpoints of the sides D, E, F. Right? All these things are somewhat simple, but they are very powerful in solving the problems. So you need to memorize all these things to solve the problems. Just have a look and go with a screenshot right now. Right? I will give you one more thing, right? And what it is? Yeah. Right. 8th point related to this. What I have in my hands is 8th point related to the centroid. For example, if you have a triangle ABC, in this previous 7th point, we are considering the midpoints of the sides and we discussed something. Now you just consider the centroid of the triangle G, right? And if you join GA, GB and GC, just have a look. Now clearly these 3 triangles also have equal areas. Area of triangle GAB is equals to area of triangle GBC is equals to area of triangle GCA is equals to 1/3 area of triangle ABC. For example, in the problem itself, if the coordinates of A are given, coordinates of B are given, and coordinates of C are given, G are given, and if they ask you to find the area of triangle ABC, see, there are 2 different ways. Find coordinates of C first and then find the area, or otherwise just find this area and then multiply this area with 3, you will get the total area. This is also one important relation related to the centroid for the triangle ABC. Just have a look and again go with the screenshot. This is the 8th point, right? As I mentioned you, I will give you 10 points related to the centroid, right? So then I will give you 9 and 10, just have a look. Now, the 9th point related to this, right? 9th point. Every point is simple and but useful to memorize. The ninth point is, if you have a triangle ABC and if this G is the centroid, right? Now we have a relation that AB square plus BC square plus CA square is equals to 3 times of GA square plus GB square plus GC square. Just observe it. Just have a look, observe it. See, square of this side plus square of this side plus square of this side is equals to 3 times the square of GA, square of GB, square of GC. You have a chance to prove it also, right? See, somewhat algebraically somewhat lengthy, but you have a chance to prove. Let the coordinates of this A as x1, y1, coordinates of B as x2, y2, and the coordinates of C as x3, y3. With these three, you will get the coordinates of centroid as I mentioned you in the first point, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. We have the coordinates of ABC and then coordinates of G also. Find distance AB, square it. Find distance BC, square it. Find distance CA, square it, and add all these things. That is your left side part. Now find distance GA, distance GB, distance GC, square and add this. You will get this relation, right? Now just I am mentioning you the relation between the side lengths along with this GA, GB, GC. Just keep in mind, and if you face any problem related to this, you need to answer that using this relation. This is the ninth point related to the centroid of the triangle. And I will give you one more point, and there ends 10 points related to the centroid, which are very useful to solve many problems, right? Just have a look and I will give you the 10th point. The 10th point is also like this. Yeah, I am mentioning you the 10th point. I have a triangle ABC and the vertices ABC as x1, y1, x2, y2, x3, y3. And not only that, I have the centroid of the triangle also, right? And now, if P is any point in the triangle, if P is any point in triangle, right? See, to prove all these things algebraically, it needs some space and then time, right? Now to solve the problems, you need to memorize the tricks, you need to memorize the formulas. So now I am mentioning you only those formulas, right? Now ABC is a triangle, G is its centroid, P is any point in the triangle. Now what I have is PA square plus PB square plus PC square is equals to GA square plus GB square plus GC square plus 3 times of PZ square. PA, PB, PC. Distance from P point to A, P point to B, P point to C. GA, GB, GC. Distance from centroid to these 3 points ABC. And PG. Distance between the arbitrary point with the centroid. And now at the end, this is the relation useful to solve few problems. Right? Have a look, and this is the 10th point related to the centroid of the triangle. Now there ends my views and my points related to the centroid of the triangle. Just have a look, go with a screenshot. See, all these points are helpful to solve the problems. We are very familiar with the basic formula of the centroid as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. See, that formula is very useful in most of the cases. But along with that formula, if you have an idea about all these 10 points, these points automatically save your time in examination and as well as at the time of problem solving. Right? Just have a look about all these points and they are much helpful to you. Have a look.